Alright, I know a handful of us still aren't quite done. I think the majority of us who were here before the bell rang are done, so let's start going over these. And also, don't sweat not fully completing it. I need y'all working on it. But I also understand we may not have quite the amount of time as we want. This is more of getting a gauge, or this is helping me figure out how well the class understands key ideas. So I'm collecting it, we'll go over it, and then we'll get started on today. Alright, by the way, what is due tomorrow? We'll have it at the end of class. I'll show it at the end of class as well, but what's due tomorrow? Homework 8 and 9. Just homeworks 8 and 9. Because don't forget, I told you that I'm going to take 20 off. That'll be due on Monday. So it's just homeworks 8 and 9 that we have due tomorrow. And once again, right, we're going to have a couple minutes in class today for you to ask questions. Take advantage of that. And if other people are asking questions, you should probably write some stuff down, because I saw a lot of people miss questions or miss points on questions, even though it's stuff that I know we talked about in class, but certain people asked questions about it. Are you allowed to collaborate with people? 100%. The best learning I did in college was when I sat down and talked through ideas with other people. Usually I had a pretty good grasp on the math ideas, but me explaining what the question was asking and how I approached the question helped me learn it better. Them talking about it and asking questions of me helped them learn it better. Collaborate out the wazoo. I'm totally okay with that. Just be careful that you're not plagiarizing or taking the exact same language that someone else is. That's the key difference. But use each other's resources, 100%. But also, and I think I mentioned this yesterday, what other resource do you have that most of us did not use whatsoever? Your notes, right? The notes go along with the work that I've assigned, so make sure you use those notes, please. Alright, so let's look at this. So create an overall question, not a survey question, that is statistical in nature, and we'll collect categorical data. So, notice if it's a survey question, you're going to be directly asking it to someone. And when I look up here, I see a handful of survey questions. Actually, I see one right now. Does anyone see the one survey question that's up here? I see one survey question that's not an overarching question. So let's number these. Does anyone see it? It is not 2. Now, I will say this. Is 2 a question that you're going to collect data from people? No, that's just a statement, right? Remember, if it is a statistical question, then it needs to be a question. How could I translate that into a question, though?
Put is.
Okay, so is football the best sport?
Question mark.
Okay, question mark, right? Do students, and so notice the difference here, do students at Hillcrest High School believe that football is the best sport? Could we get variability in that response?
I just couldn't type that much. It was like, they're not
It's not a QWERTY keyboard. Yeah. So really quick detail, you know why they're not in a QWERTY keyboard? Because the ACT has it specifically said that you cannot use a calculator that is QWERTY based. But you can have this keyboard. Why? Who knows? Yep, it's dumb. I don't know. It's a rule from the ACT, and so I know we're not used to it, and we gotta get used to it. Does that make sense though? The difference between football is the best sport and do students at Hillcrest High School think that football is the best sport? We good with that idea? Okay. And so we would fall into yes or no's, trues or falses. That would be a category. Does anyone see any questions up here that might be numerical data and not actually categorical data?
How many birds are all black?
How many birds are all black? Say again. How many roses are in the forest? 4. How many cars park in the parking lot over a week? Notice all of those answers will be what kind of responses?
Numerical.
Numerical, right? Now, one thing I want to point out here, if we say what is the average person's favorite animal, that's going to be the word average, right? So I know from an English perspective that might be correct, but average really means an average, right? A numerical average. So we might not want to say average in that case. What could we say instead of average person's favorite animal? Okay, so what is the typical person's favorite animal? That could work, right? Another thing I want to point out, other than my soul hurts right now, the other thing I want to point out is this, and this is something I have not covered well at all, because I'm looking at these answers and I'm not seeing it. What is the population of interest? When we say forest, what forest?
The forest.
There's only one forest in the entire world?
No, but there's a.
Are we talking about forest in the United States? Are we talking about forest throughout the world? Are we talking about forest in Alabama?
Well, that's the fact of where the variability comes in, is because it can be any forest, so it can be any number, so it's numerical and statistical.
So it's numerical, it could be statistical, but we need to clarify what population we're talking about, right? I don't know if you heard it when I said this, but how many, where was it? Maybe it was here. How many cars parked? No, that's not what I was thinking about. Oh, up here with football is the best sport. I said the question could be, do students at Hillcrest High School believe football is the best sport? What's the population I'm thinking about there? It is the school Hillcrest High School, but who? Is it everybody at Hillcrest High School? Just the students at Hillcrest High School, right? I could change that question and say, do students in Tuscaloosa think that football is the best sport? Is that a different population that I'm talking about? Yes. It's the students of all of Tuscaloosa, not just Hillcrest. Do people in Tuscaloosa think football is the best sport? Am I changing the population again?
Yeah.
Yes. So one thing that I do want you to think about and move forward with on this, and this is my fault for not addressing this better. I always had it in the question, but I didn't address it. You got to identify what your population of interest is. Who are you asking this question about? All right? So one, do we understand that there needs to be a population involved? We good with that? Two, it's got to fall, the response has to fall into a category, right? And three, that response needs to have what? Variability. Well, remember, population was the first thing, and there needs to be variability in the responses from the population, right? By the way, the one, did we already talk about which one is a survey question and not an overall question? It's 6. Remember, a survey question is what you're going to ask somebody, right? What all states have you been to? So, maybe we could make that, what is the most, what state has been visited the most by students at Hillcrest High School, right? Now, and so like when you ask the question, what all states have you been to, you're going to collect the data about all the states that person has visited, and you can figure out which state people have visited the most. But again, what's the population I'm looking at there? Hillcrest High School students. And that's different than just Hillcrest High School people, because that would include teachers and administration and things like that. You got to clarify what your population is. Does that help us understand this a little bit better? Okay.
Would that be a population in its own, though, if you just said Hillcrest High School people?
Correct. And it's a different population. That's my point, right? Yeah. That's why I have to clarify what population we're talking about. Is it Hillcrest High School students? Is it Tuscaloosa students? Is it just anybody at Hillcrest High School? The population changes kind of how we think about our responses. So then the idea of defining equivalent equations, it looks like we have a pretty good handle on this. So I see equations that look different but have the same solution, equations that have the same solution and make that solution true. What can we modify about this one to make it a little bit more accurate? Equations that have the same solution.
The solution makes it true.
The solution makes the equation true, right?
Yeah,
So do I need to include this here?
No.
No, right? Just equations that have the same solution. Okay? Do I need the word equal here? No, equal is that statement, that mathematical statement, right? So equations that have the same solution. So we've got a lot of those. Is the solution ever not going to be true?
No.
No? A solution will always make the equation or the inequality true. So we don't need to include that. We just need to say they have the same solution. Okay, someone just said equivalent equations, right? But, I mean, define it, right?
You need to get to finish the word.
Yeah.
One of mine is up there. It's going to be like,
Even answers, so equivalent equations only have 2, 4, 6, 8, 10 as their answers. Do we think that might be equal answers or the same answer? Hopefully.
What was the question?
At the top it says define equivalent equations.
The equations that have the same solution.
All right. One thing I want to modify about this. Yes, they are equations that have the same solution, but do you have to work or solve the equations to know that they'll have the same solution?
No, not all the time.
Not all the time. So we don't need to know what the solution is. In general, remember, they are equations that look different, but what?
They're the same.
That, not just the same solution, that look different, but you're still going back to the solution. They're equations that look different, but are the same, right?
Well, they're technically different, but they got the same solution.
Not necessarily. Here's the reason why I say that. Yesterday, we worked on this equation, 3.6c plus 7.5t is equal to 21,600. That was the equation that represented how many cars and how many trucks could fit on that cargo ship, correct? Okay? When there's two variables, can I have a solution? I mean, I could get two values, but like right now, will a single number, I should say, will a single number make this equation true? No. But remember, we got to the end yesterday where we had this equation. And we also had this equation.
What do you divide?
We'll address that during the small group discussions. Okay. Were those three equations equivalent?
Yeah.
We worked through that. We talked through that, right? Those look different, but they're still the same. And they don't necessarily have to have the same exact solution right then because there's not, I will say the same two values will make that equation true, but they don't have to be a single answer, right? They just need to look different, but they're still telling the same story.
Oh, I know how to do it now.
Okay. I'll say, we'll talk about it. But please remember, right, equivalent equations look different, but they tell the same story. And the next part of this is really important, right? What properties create equivalent equations? Properties of equality. I see that. I see an I don't know. Hopefully we learn that it is what? Even if we misspell it? What properties? Properties of equality, right? So that's the other thing, right? Equations that look different but are the same. That means that we used properties of equality all the way through to maintain equivalence. That's a huge detail there. There are a handful of other properties that can maintain equivalence. Does anyone remember the other two we've talked about? Distributive property, right? We can distribute. We haven't gotten to inequalities. What was it? It does start with a C. It is the commutative property, right? Is 3 plus x equals 8 the same thing as x plus 3 equals 8? Yeah, right? That's where the two numbers on the two numbers or two values in one expression switch places. Notice I didn't go across the equal sign, but the commutative. Is that what you're going to ask?
No, I had a question about that part. So when the sign
That's a great question. So if I have x minus 3 equals 8, right? What value would make this equation true right now? No. Just what value? What's the solution to this equation?
Sorry.
Not 5.
11.
11, right? If I just switch these, is the solution still 11?
No.
3 minus 11 is 8?
No.
No. So notice how we're subtracting 3, so that's a negative 3. You see how x is positive? So it would be adding x. Negative 3 plus 11, that is equal to 8. So you see how the signs have to go with them to maintain the equivalence, right? Because I still need to be subtracting 3. So excellent question on that side. Ready to move forward? All right. I heard some people frustrated or grumbling about one of the questions yesterday on the quiz. So that's why I created this question here. Wait, did we not get an answer? Why is it not showing me the data? All right, well, let's talk about it. Let's look at it. I don't know why it's not showing me the responses. So, all expressions that are equivalent. What can we do to find equivalent expressions?
With the exponent.
Okay? So what am I going to do with this exponent here? Kind of. What does it mean to square something?
Multiply by itself.
That's it, right? If I have an exponent of 2, I'm just multiplying 3x squared times 3x squared. A lot of people try to memorize all the different exponent rules. Don't. Just remember what the exponents mean. Yeah, you can do 3 squared easily, but notice 3 times 3 is what? 9. What's x squared times x squared? So is this one of those things we're not quite sure of, right? So we think that we would add those exponents. Does anyone know of a way we could check that?
The internet.
You could use the internet, but also, what does x squared mean? X times x? And then I'm multiplying by how many more x's? So what is that?
4.
Not 4x. X to the 4th. So could we have just added those exponents?
Yeah.
Yes. Notice when I did, okay, I'm squaring it, I went to the basics of I'm just multiplying that by itself. I wasn't sure what x squared times x squared was, so I just broke it down of x times x times x times x. Oh, that's 4 x's. So one of the expressions that was equivalent is I used the commutative property. That was one of the equivalent expressions. If anyone saw that one. Notice how I commuted these two. Okay. Another one that was equivalent was if you distribute, you get 9x to the 4th minus 2x to the 4th plus, and that's where you need to be careful, negative times negative is positive. That was one of the equivalent equation or expressions. And then what would I do from here? Okay, what's a more mathematical term?
Can you add
Simplify. Huh?
do you add the to it, like, if they have the same exponent, it's just negative and positive, like, wouldn't those cancel each other out? Positive 2, negative 2?
Mm-hmm.
But then the exponent would still remain, wouldn't it, because you add it, so wouldn't it be like x to the 4th is just left or something?
So let's talk about this again. We'll just focus right here for now because this will be easier. Go back to the fundamentals. What does multiplication mean?
Repeated.
So what am I adding here?
2x.
See how I have 2x to the seconds? But then I'm doing what? How many? Or subtracting what?
2x.
So subtracting 2x to the seconds.
Yeah, that's what I'm saying, so wouldn't you just cut that out of any of the equations?
What is x squared minus x squared? 0. X squared minus x squared? So 2x squared minus 2x squared is 0, right? Similarly here, I am adding how many x to the 4ths? 9, and then what am I doing? Subtracting 2x to the 4ths, so I'm left with, that was the final.
Oh, sorry, I just got ahead. I didn't know you were gonna do that. I thought you were just wrong, inaccurate, you messed up.
I mean, I could have. What did you think I was wrong on?
Nothing, you just hadn't done it yet, like,
Oh,
that was,
yeah,
that
yeah.
was your next step, and
I was
kinda-
focusing here because I'll be honest, it's way easier to do 2x squareds than it is to do 9x to the fourths.
Yeah, I just.
That's why I was like,
jumped ahead.
I'll leave that alone for now.
Mhm.
Do we have any questions before we actually get to today's lesson? I know that was a long time on the warm-ups, but hopefully that helps us understand these concepts better. Yes, sir. You have your other homework to turn in? Hold on to it for a second, and I'll come get it. So don't forget, every day the homework is late. It's 10% off, but that's still way better than a 0. So take advantage of that. Please get that homework done.
Mine doesn't have a back,
What?
because I printed it out at home, so.
There should have been a second. Oh, is it lesson 7?
Unit 2
Number
lesson
7 and 8.
Yeah, lessons. So I went ahead and copied lessons 7 and 8 together. So if you print out lesson 7 on its own, it won't have that.
I know, yeah, I did that, so I gotta find the other one though, if I
You're
ever
good.
printed it.
We'll figure it out. I can always print it out for you. So lesson 9, which variable to solve for, we're gonna wrap that up and then have a break to ask homework questions. Hopefully lesson 9 won't take us too long. We already did a bit of a recap. Let's see, Kyla, can you read our first objective for us?
I could look for it in express regularity and repeated reason.
Okay, and that's our S&P, sorry, I should have clarified. That's 100% right though. We do want to be looking for and expressing regularity in repeated reasoning. And so that means, hey, I can recognize a pattern and use that. Remember yesterday with the cargo ship and the trucks and the cars, and you worked through the first 3 that had values plugged in for the number of trucks? You remember that? Right? There's 480 trucks and then 1,500 trucks. And then the process you used to solve that equation, wasn't that the same exact process we used here to solve for this C? That's what we mean by looking for and expressing regularity in repeated reasoning. It's one of the ways, right? So that's what we're looking for. Let's see, from there, KJ, can you read our second objective for us, please?
Wait, what?
The second, or the first objective, sorry, the actual objective.
Given an inequality, I can solve for a particular variable, like height, time, or length, and the equation would be more useful in that form.
Right? So that's what we kind of looked at here. Why would I want to use this equation? What would be the purpose of this? To find C, so that means I have which value already given. T, right? If I know the number of trucks, this equation is going to be really easy to figure out the number of cars. Right? Lexi, why would I use this equation? Because I'm trying to find T, what was that again? Number of trucks, right? If I'm trying to find the number of trucks, then I know the number of cars. You good with that idea? Alright.
Yeah, 2 times 2.
Let's see here from that point.
I think you're supposed to-
Nathan, can you read our second objective, please? Okay, know the meaning of the phrase to solve a variable. We started to see it here. What does that mean to solve for a variable? If I asked you to solve this equation for C, what am I asking you to do? Okay, I already found C, it's right here, found it. So what do I mean by solve for C? There's no solution really. Okay, but I mean, have I found it? This is I've already solved for C. This is an example of what I mean by to solve for C. So what do I mean by that? DJ, you're getting frustrated because you were close, but like it's that language we need to be careful about. Here's C, I don't need to find it, it's there. So what do you really mean when you say find C? But notice this is an expression over here. I don't know the total number of cars. How many variables are on the left-hand side? Or how many values are on the left-hand side? Just one. What is it? C. So I've solved for C, the number of cars. That means that the variable C, the variable I'm solving for, is the only thing on its side of the equation. That's what we mean, right? We can't say find the solution because, well, there is no solution. There's an expression, right? I can't say just find C because that's a little vague. That's what leads to lots of great memes on the internet about, here's this right triangle, I've circled X and found X, right? I need to solve so that C is the only variable on its side of the equation, using those properties of equality, things like that. Alright, so that's a recap of what we did here, so let's jump into the next part. where it talks about the Department of Streets, which I meant to check to see if you did number 1. We don't have time for it now. We should have, at least most of us, hopefully some of us, wrote an equation for number 1 here. What is the equation that represents the relationship between the miles of 2-lane roads the department could resurface M, and the number of new workers it could hire P if it spends the entire budget?
Where's your turn-in thing?
The what?
Your turn.
Just hold on. I need to update that back there. I haven't done it yet. Just hold on. I'll come collect it while y'all start working.
I'm just gonna say.
Yeah. So what was the equation we should have written here? Hey Grayson, it helps if you wait, buddy. Take a pencil. Pull out 9.3. You need a pencil?
Y'all should, why don't, I know it's confusing for some people, but if y'all already do the schedule, like, where you don't have the same schedule every day, like, you have the same classes, they're just swapped around, it's better, because you won't have all of us dead in math. Like, I don't think I've gotten anything from this class, because I'm half asleep in it, no
Yeah.
offense, it's the math, it's not you, and the fact I have to wake up early.
I mean, I get
But if I
that.
had this, like, third every,
Here's the
like,
thing. I've
Wednesday,
actually
you know.
done a rotating schedule. It doesn't help.
Was it confusing for you?
It wasn't confusing, it just didn't help students. There was this theory that it would help students, and I've looked at it, there's been a lot of research that says it doesn't actually help students.
I think what would help students the most is school being later.
Now, I will agree with
Not
that.
like a whole lot later.
There's 2 things timing wise I wish we would do. I wish that we would start school at 9 instead of 8. And I would honestly, and y'all can shoot me down on this, I wish that we would do school, doesn't sound crazy at first, 9 to 5, and then have Fridays off.
Yeah.
Do 4 10s.
And then we have a 3-day weekend?
And then you have 3-day weekends. I would suffer for 4 days to have a 3-day weekend. And then for all y'all who are like, well, I need to work, well then you'd have an extra day to work and be able to be a student during the other 4 days. That's my theory. I don't know if